it was actually developed. Good catch. It almost spilled.
No, I wouldn't have spilled. It might have spilled. It might have shot right off the edge of the table.
Yeah.
Okay.
Yeah, we're balancing the phone against a cup with water in it. So
Our professional setup.
very professional. So, payback.
This is Isaac, my genius son.
I think we're past the introduction.
This is pointing it out.
Okay, so
Did we get into the third one yet?
yeah, we did Calabi, L-manifold, quantum foam, and strings. But Werner Heisenberg developed the uncertainty principles in 1927, but Erwin Schrödinger developed Schrödinger's cat. Oh, you already explained that at the beginning, didn't you?
Mm-hmm.
And there are a few quotes by Werner Heisenberg that I find completely fascinating.
A little bit off subject, but they are. The first one is just amazing.
Werner Heisenberg says, "What we observe is not the nature itself, but the nature exposed to our method of questioning." That is a really powerful quote if you think about it.
It's very powerful.
Very powerful. What we observe is not the nature itself, but the nature exposed to our method of questioning. So, if we ask a different question about the same subject, we'll get a different answer. So, if in another universe with the exact same laws, the exact same everything, if we ask different questions, our view of science could be completely different.
Our perceived laws of the universe could potentially be different. We would have a different understanding.
Yeah, friction could be a force of the universe. You want to read the other two?
Yeah, natural science does not simply describe and explain nature. It is a part of the interplay between nature and ourselves.
It's not exactly a powerful quote, though.
The first one is what really caught my eye. And the third one?
Are you going to read it?
Sure. The first gulp from the glass of natural sciences will turn you into an atheist. But at the bottom of the glass, God is waiting for you. What do you think that means, Isaac? What's the implication?
God is metaphorical. What it means by God is the reality of nature, the nature of the universe.
Einstein said something of the sort one time, not long before he passed, and for many years he's been misunderstood, but what he was saying was metaphorical. Okay, on to supersymmetry, note that we want to point out. A model in which the equation for forces and matter are identical. Okay, that's the definition. But supersymmetry is not a theory. It is a principle that a theory may have.
It's a common misconceptualization that it is a theory, but it is a real thing.
Definition: supersymmetry. A model in which the equation for forces and matter are identical. Isaac mentioned that earlier in the video. Okay, back onto the subject of quantum mechanics. There are many effects, but we're going to delve on three of them.
Yeah. That's quantum entanglement, quantum superposition, and quantum fluctuation, and we've already done quantum tunneling. So which one should we do first? You pick. That's why I asked you.
First one.
Quantum entanglement?
Yeah.
So quantum entanglement, Einstein nicknamed it spooky action at a distance because it is kind of weird. But quantum entanglement is pretty much when two subatomic particles become entangled. And what that means is
one has a counterclockwise spin and the other has a clockwise spin. Right?
That's not the whole thing. That's there's a lot more to it. You want me to go?
Yeah,
Sounds like you're about to say something. Okay, so when two particles are entangled, no matter how far apart they are, they share an instantaneous transfer of information. So one could be in the Andromeda galaxy and one right here. And the second I reverse a spin on this one, instantaneously the one in Andromeda galaxy is reversed, which is Andromeda galaxy is light years away, which nothing can travel faster than light.
So the effects are going to be instantaneous.
Yeah.
So there has been experiments done here on Earth, many experiments that proves quantum entanglement. We can do things we do the experiments over different continents away from each other, thousands and thousands of miles, and the effects are instantaneous.
Okay, and what was I about to say? Okay, so anyway, quantum superposition, it states that a quantum particle, when it's not being observed, can maintain multiple positions. So you have a single atom, and you're not observing it. Oh, we forgot to do the double slit experiment. A single atom, you're not observing it, and it's in 70 places at once, 100,000 places at once, or just the same place. It can be in multiple different places at once. The same particle, the same existence.
Until it is observed by a person or whatever entity, and then it is in a determinate position.
Yeah. And once you determine the speed of a particle, its direction changes, and vice versa. That's what the uncertainty principles is about. You can know how fast it's going or where it is.
But you can never know both at the same time.
Okay. And quantum fluctuation is just a change in the energy of a quantum particle. In the double slit experiment,
you were talking about quantum fluctuation.
yeah, it's just a change in the energy. It's nothing too advanced.
Yeah, but it's particles seep in and out of existence, though, right?
Yeah.
And one theory on it is that is where we keep on getting matter from. You have trillions of these interactions, and a particle disappears out of existence. But one out of a trillion, one particle stays, and that's where we keep on getting matter in the universe.
Yeah, because the universe is still expanding, and you're thinking, where is all the matter coming from? That's what dark matter is. But matter is always being created on an infinitely small scale. Which infinitely small is still smaller than the three makeups of quantum mechanics. So I'm not sure about that exactly. The quantum world is really strange. It's actually known, quote, in the quantum world, in the world of quantum physicists, the second you think you understand quantum physics, you don't. Because it's really hard to understand, it's always changing. It's really weird. But the double slit experiment, who was it developed by?
You know, I was thinking about the other day, the statement you made, but somebody on YouTube was talking about that they know of two people in the world that actually understand quantum mechanics. But if the person making the statement doesn't understand quantum mechanics, how can they possibly be an authority on who understands it? Okay, go ahead.
Okay. Developed by Thomas Young. It was an experiment by Thomas Young, and basically they had, I think, a sheet of metal, but the material that it was made out of doesn't matter, with two slits in it, two holes, and it'd be a good idea for a t-shirt. Two holes.
Double slit.
Yeah. And they would fire protons through it, and when it's being observed, the protons would only go through one hole, and they would act as a particle. But when it's not being observed, the exact same particle would be in two places at once and go through both slits as a wave.
And create a wave pattern. From two different slits, the pattern crosses over, and where the photons would strike on the other side, they would be able to see impacts from particles.
Yeah.
But the moment that it's observed,
If you observe it after it's passed through the slits, but before it hits the measurement,
it appears to have went back in time and
change its trajectory. So a quantum particle will go back in time and change its trajectory.
it certainly appears that way.
which going back in time is the same thing as antimatter does, but it's not antimatter.
That's the theory too, though. Antimatter going back in time.
Yeah. You want to explain antimatter? Make the video a little long.
No, we don't need to go into antimatter right now.
I think it's pretty fascinating.
Yeah, it is. Yeah, it is.
I
But
have
if
all
we're
my
trying to do
research right
20
here.
minutes here, I imagine we're definitely there.
Okay.
Any other subjects or parts of the subject that you want to cover in this video? Okay. Well, I believe that's it for this week. Anything else? Okay.
We should do positronium next.
Positronium.
Maybe azido.
Anyway,
We'll have to do that face again.
good night.
Do the face again.
What, Alan? Oh.